Hello everyone, welcome back to my channel. In today's video, I'll be explaining my project Plagiarism and Near Duplicate Detection using Shingling, MinHash and Locality-Sensitive Hashing. So plagiarism is a major issue in today's digital world where a lot of document content is easily accessible. Detecting copied or slightly modified text in research paper or online document is quite challenging. Our project aims to detect such similar or near duplicate document efficiently using data mining concepts like shingling and locality sensitive hashing. Plagiarism doesn't mean always exact copy paste. Sometimes the words are rearranged or sentences are reordered or words are replaced with the other words. So traditional methods that compare entire document word by word are too slow when we have thousands of files. So our goal is to detect similar documents accurately and quickly even when small edits are made. So we use shingling, minhash, and locality sensitive to solve this efficiently. So let us see what is shingling. So, shingling is the project process of dividing a document into overlapping sequences of words or characters called shingles or engrams. This helps to capture the structure and meaning of the text. For example, in the example it is given data science is very interesting subject. So we will take k equal to 2, which means the length of each shingle is a two words. So the shingles formed are data science, sciences, very interesting and interesting subject. So once we have shingles, we need a way to compare document efficiently. Directly comparing all document is so expensive. So we use minhash, which convert large data set into a signature that prevents similarity. If two documents are similar, their signature will also be similar, but the data size become much smaller. This makes comparison faster and scalable. So let us see an example for this. So here you can see we are having two docs. Document 1 consists of a data science is interesting and document 2 consists of science of data is interesting. So we have taken the value of k equal to 2. So we will get shingles for document 1 as data science, is interesting, and shingles for document 2 science of data is and is interesting. So we will get the respective shingles. So now we want to assign hash values. So generally hash values are generated using random hash functions, or we can use an inbuilt library in Python called as hashlib. So I have already created randomly. I have randomly given some hash IDs to these shingles. We will consider these hash IDs for further calculations. So we need to define an hash function. Generally, formula for hash function is hash function of a shingle is equal to ai into x plus bi mod m. Here a and b are constants. We can take any constants. M is a modular number, which actually we should take a large so that the hash values are so accurate. So we are taking 31 for this example, which is a prime number and a larger number. As our data set is very small, 31 is very efficient for this. So here you can see for a hash 1, I am taking 2 as A and 1 as B. And for a 2, I am taking 3 as A and 7 as B. We can modify it. We can take 1 to any other random values we can take as our wish. But I am taking this. So for H3, I am taking 5 and 11 as AB values, and mod M is 31. It is same for all. So now let us calculate a hash function to all shingles. So here you can see we are having columns like shingle ID, H1, H2, Hx. So as you have seen, the formula is A into X plus B mod M. So here we have for H1 we have taken a as 2 1 and m equal to 31. So you are here you can see 2 into x. What is the id for this single data sense? It is 12. So 2 into 12 plus b, we have taken the value of b as 1. So plus 1 percent 31, we have taken m value as 31. So percent 31 equal to 25, like that for h2. So 3, we have taken a value as 3 and id is 12, b value as 7. So percent 31 same. So same like that we will calculate for all hash functions and for all respective shingles. So now for each document we are having, for document 1 we have shingles. So here you can see document 1 consists of data science is interesting, and doc 2 is science of data is interesting. So here we got doc 1, uh, 12, 20, 25 and 5. See here these three are the shingles of D1, and doc 2 shingles are 8, 15, 30 and 5. So these are the shingles of doc 2. Now we are taking the signature for doc1. Here signature comes for each hash function inside the shingles. So for document 1, these three are the shingles. Which is the lowest value among 25, 20 and 11? So 11 is the lowest one for h1 function. So we are taking 11. And among 13, 19, 22. So 13 is the lowest one. Also for the h3 function you can see 35 and 6. So among these three, 5 is smallest one. So we are taking 5. So signature for document are 11, 13 and 5. Here you can see signature for doc 1, 11, 13, 5. And then we are coming to document 2. So we are having shingles of 5, 8, 15 and 30. So here in this, from this 0 is smaller, and from this also 0 is smaller, and from h3 we can see 6 is smaller. So signature for doc 2 is 0, 0 and 6. So now we have successfully calculated signatures for the given data set. Now we will apply locality sensitive hashing. So after min hashing we will apply locality sensitive hashing. Here LSH divide each signature into several band and hash them into buckets. Document that land in the same bucket uh, are likely to be similar. This way we don't compare every pair, only those in the same bucket. So after dividing them into band and keeping them in bucket, we will compare the document which are present in that particular, so that we don't need to compare all the document present in the corpus. So this reduces the time and it is more efficient. So let us see its execution. I have written the code in Python in Google Colab. I have given already given three txt files consisting of some data to check whether they are plagiarized or not. See here you can see I have created a folder and I have given three documents. Here you can see the text in doc 1. So the text in doc 1 is data science is an interesting topic. So like that three different document consists of three types of text. So I am importing libraries like re hashlib already I have told to generate random hash functions, and random to generate random dot zin, and I have used iter tools and pandas. So the first function itself is load document. So we are loading the document from the document named ir to here. So to check whether all the documents are loaded correctly or not, I'm just printing them. And then here we can see shingles. So I have written a code get shingles. So we are getting text and k value as the parameters to this function. So I am removing parameters and converting the text into lower and splitting the words. So now I am returning it as a set into the shingles. So here you can see I'm storing this in shingles. Now we will print them. So here document 3, here I have taken the size of k equal to 1. As my document contain very low data, I have taken k equal to 1. If there is much more, we can take k value as 10, 15. For larger data set, the k value 10 is as efficient, and for smaller we can take 1, 2, 3. So here you can see document 3 consists of mesh and is and some other. So document 1 consists of an is, and doc2 also consists of an is. I can also show you by keeping two. So let me run this. So here you can see doc3 consists of data. So shingles are of size 2. Now going to the min hash. So now we are creating signatures over here. So you can see num hashes. It is the minimum number of hashes. We are taking 20. In the example I have shown, we have taken just 3 hash functions. But here we are taking 20, minimum 20 to 100 hash functions. And we are having a signatures uh, to store the signature and random dot seed. So to generate the same random function every time. So we are having hash functions. So a comma b, I have already said a comma b are some constant. So for every hash function we are calculating signatures. So here you can see the formula, value equal to a into h plus percent hash underscore max underscore hash. So and then we are storing the signatures. Here you can see I'm printing them now. If we have taken min hashes as 1000, then we will get the signatures in 1000 values like 13,000, something like that. It will all depend upon the hash functions we are taking. And then now we have came to locality sensitive hashing. So here we are having signature and the bands. So after that we are having hashes. We are calculating hashes as the length of signature. So here we need rows to calculate. So we are calculating rows as number of hashes divided by band. Let us assume we have taken here num hashes as 20. So and for suppose we have 5 bands, so we will be having 4 rows. We need to sort these shingles into particular buckets, right? I mean documents into buckets. So we are having buckets to store the respective document, and we are uh, pairing them into candidate. So we have written this code for that one. So after that we are having similarity. We are calculating whether how much similar both documents are basing upon min hash similarity. And then here you can see we are having an result array where I am storing the results of the documents. So we are first doing shinglings. We are dividing it into shinglings, and then we are calculating signature vector using min hash, and then we are applying locality sensitive hashing, and then we are uh, comparing the similarity using min hash similarity. Here you can see if the similarity is greater than or equal to 60%, then the document is plagiarized, or else the document is not plagiarized. Now I am printing the results. So here you can see document 1 and document 2. They are 60% similar. So the document is plagiarized. If we take more content, then the min hash similarity will be more. So thank you for listening. Have a good day.